today. It kind of goes along a little bit with what we did with unit rates, but just to build on our number sense a bit. And it helps us to solve equations, so we'll just kind of reinforce this. So the learning goal for students is to understand the significance of part-to-part comparisons or ratios. So if we were to do this in class together, I would have had you select a total of 9 linking cubes. But since we're not together, I will select them for you. So with the blocks connected and the same colors together, shade the cubes on the diagram below. So this is what I would have picked. I would have had 4 pink cubes, and then I would have had purple. 5 purple cubes. So my part-to-part comparison would be made up of pink and purple cubes. And I would have showed them to you like this. Whatever you guys picked, you could have picked 3 and 6. Either way, you would have had your parts indicated as so. So now indicate the number of cubes for each color. These are called parts. So I have part of pink, and I have purple. Oh my, part pink and part purple. So now I have created a part-to-part comparison. So I have 4 parts pink and I have 5 parts purple. So if we wanted to, we could use this notation to show the ratio in 3 ways. So I could have 4 to 5. That's not. I'm going to write it in. So I could have 4 to 5. Or I could have color 4 to 5 with a colon. So a colon denotes that it's a ratio, 4 parts to 5 parts. Or I could write it as a fraction with 4 to 5. So either way, this is how you can set up the ratio. So I've got 4 pinks, 5 purples. In words, 4 to 5. As a ratio, 4 to 5. Or as a fraction, 4 to 5. So we can create a different combination with the same number of linking cubes. So if I'm going to create a different combination, I'm going to have 3 pinks this time. That got a little out of control. And then I'm going to have 6 purples. So in this case, I've got 3 parts pink to 6 parts purple. So if I write in here pink, and these ones are my purple with 3 and 6. So if I write in words, I've got 3 to 6. If I write it as a ratio, I've got 4 to 5. And if I write it as a sorry, I just wrote the same thing. Using my new ratio, I've got 3 to 6. And then if I write it as my fraction, I have got 3 on the numerator and 6 on the denominator. So just kind of writing fractions and ratios using words and numbers. So if we select 5 cubes, 2 of one color and 3 of another, so we're back to making our cubes. So 2 pinks and then 3 purples, I've got parts of holes here. So I've got part pink, I've got 2, part purple, I've got 3, and total, all the colors, I have a total of 5. So the ratios for pink is 2 to 5 of holes. For purple, I have 3 out of 5 as holes. So this is, we're looking at parts of the whole. So it says now select 5 cubes. 6 are the first color and 9 are the second color. So again, if we start to shade, this works better if we were in class doing it for real. So 1, 2, 3, 4, 5, 6 pink, and then I've got 9 purple, 1, 2, 3, 4, 5, 6, 7, 8, 9, 15 cubes altogether. So can you see relationship between the two diagrams? So let's take a look what we've got here. So I've got pink, I've got 6, purple, I've got 9, and total I have 15 cubes. So let's see. If I look at my ratio of 6 out of 15, and I look at my ratio of 9 out of 15, can you see the relationship between the two diagrams? What if we reduced this fraction to lowest terms? So let's start with the pink. Let's reduce this to lowest terms. So if I divide out a 3 from the numerator, I'd be left with 2. And if I divide out a 3 from that denominator, I'd be left with 5. Similarly, if I reduce this one to lowest terms and divide out a 3 from the numerator, I'd be left with 3. And if I divide out a 3 from the denominator, I'd be left with 5 as well. So what do you notice? They are equivalent. So we increased it by the same ratio. The total amount increased by the same ratio, and each color proportion increased by the same ratio. Another way of representing it would be to use parts of a whole, so bubble bars. So here, if we were to put in a number using our pinks and our purples, I'll use pink because pink was 2 and purple was 3. So we have our whole is 5. We have part of our whole being 2 and the other part being 3. So you can represent proportions in different ways. So when we use the ratio as a rule for how we want something to look, it's called a proportion. Use your ratio with 5 cubes as a rule to create a longer strip of 15 cubes. So we did this. So we said pink to purple. I have to write it in with this. So we've got pink to purple. I'm not sure why this keeps going down. That's so weird. Pink to purple. And we had 2 pinks. We had 3 purples. So we can say we can solve a proportion in this way. So I'm going to pull it out, make it look a little neater so it's not shrinking as I'm writing. So 2 pinks to 3 purples is equal to 9 purples over how many pinks. So I'm going to fix this. Should say 9 at the bottom here. This should actually be a 9. So how many pinks would be how many pinks would there be if we used a strip of 15 cubes? So there's a couple ways that you can solve this. You can ask yourself, how did I get from 3 to 9 using multiplication or division? Well, I multiplied by 3. Here we go again. So that means I would have to multiply that numerator by 3 as well. So just a way to solve your proportions. So these questions are going to be for you guys to do. It says the design for a rectangular garden has a length to width ratio of 5 to 7. So because this is written as length to width, this 7 represents the length, this 5 represents the width. So which of the following could be used to determine if the width of the garden was 14 meters long? So we want to know, I'm going to write it down here, 7 to 5. We want to know when the width is 14, what is this unknown? So we keep all of the width together, all of the length together. So remember from the note that we can change this. So we can change our ratio to be set up length to width this way. As long as you keep all the length across the top, so that is unknown, and all the widths across the bottom, we want to find which could be used to determine the width of the garden if the garden, if the garden length is 14 meters. Not the garden width, the garden length. So the length is 14 meters. We want to know what the width is, determine the width. This is why we read the questions more than once. So making sure the length is all across the top, width is all across the bottom. We want to find the ratio that looks like this. So when we look at this, we need to see that our x and our 5 are together horizontally. So x and 14, or 5 and 14, that can't be right because 14 is a length, 5 is a width. So similarly, it can't be here. Can't be here either because 14 and 5 are both lengths. So it has to be D. So I'm going to leave the questions 2, 3, and 4 for you guys to work on. If you have questions, send them to me, and I'll go through one of these examples, and then I'm going to leave the rest for you guys to do. A farmer has a garden with the length to width ratio of 5 to 2. He wants to make another garden with a similar shape but larger. He needs to know how much fencing to buy if the new garden will be 20 meters in length. Determine the width of the garden and the total amount of fencing needed. So we know it's a length to width ratio of 5 to 2. So we want to know how much fencing he should buy if the new garden will be 20 meters in length. So the new length is 20. How much fencing would he need? Determine the width of the garden and the total amount of fencing needed. So how did we get from 5 to 20 using multiplication? Well, we multiplied by 4. So that means we multiply 2 by 4, and that will give us the width of the garden. So that would be 8. So x would be equal to 8. So determine the width of the garden. So then we would have our therefore statement. Therefore, the width of the garden is 8 meters. But it also asks us to determine the total amount of fencing needed for the garden. So that means we are being asked basically, or we are being asked for the perimeter of the garden. So if this length is 20 meters and this width is 8 meters, we are being asked for the perimeter. So the perimeter is equal to the sum of all the sides. So 20 plus 20 plus 8 plus 8, and that equals 20 and 20 is 40, plus 8 is 48, plus 8 is 56 meters. So therefore the width of the garden is 8 meters and the perimeter is 56 meters. So just these word problems are basically setting up the proportion. Just work on these questions, guys. And if you have any questions about example 2 and 3, as well as these questions from part of the lesson, just send them to me and we'll work through them.